Hello, everyone. Today, we are going to learn about the integration methods u-substitution and partial fractions. So in video 7, you started learning about integrals. The indefinite integral is also known as the antiderivative because the integral of f of x is the function whose derivative is f of x. After evaluating an integral, you put a plus c at the end. C is just a constant. And here are some important standard integrals to remember. Here are some of the properties of integrals. And here is the role of dx, du, or d, whatever. And this might not seem really important to you, but you'll see in this video that this is actually pretty important. So u-substitution, an example problem that we can solve using that is the integral of sine of 2x dx. So in this problem, we set u equal to 2x, and then we differentiate both sides of the equation with respect to x. So to do that, the left side simply becomes du over dx. That's pretty easy. And then the right side, you take the derivative of the function. So the derivative of 2x is 2. All right, so in the end, by differentiating both sides of the equation, this is what you get. Du over dx equals 2. And then now you want to isolate dx. So multiply both sides by dx and divide both sides by 2. So now we know these two pieces of information, and then we can substitute these back into our original integral. So this was our original integral, and we know that 2x is equal to u, and dx is equal to du over 2. And then we have like a 1 over 2. That's just a constant, so we can move that to the front. All right, and then just carry the constant 1/2 out of the integral and then solve. So the integral of sine of u du is negative cosine of u. And then now we unsubstitute. So we set u equal to 2x. So now we have to set this u right over here back to 2x. So our final answer is negative 1/2 cosine of 2x plus c. This is the integral of sine of 2x dx. So here is another example. We have x cubed plus 6 and its derivative, 3x squared. So therefore, we set u equal to x cubed plus 6. All right, and then differentiating both sides of the equation, the left side becomes du over dx. The right side, you take the derivative. So the derivative of this is just 3x squared, and then you isolate dx. All right, so we know these two pieces of information and we substitute these into our original integral. So x cubed plus 6 is equal to u, and dx is equal to du over 3x squared. And we have 3x squared in the numerator and the denominator, so those just cancel each other out. And then we're left with the integral of 1 over u du, and that's just equal to ln of the absolute value of u. And now we unsubstitute. So u equals x cubed plus 6. So we turn this u back into x cubed plus 6. And then this is our final answer. So here is when to use u-substitution. When you see a function in its derivative, for example, like we just saw x cubed plus 6 and 3x squared, we saw the function and its derivative, and we set u equal to the function. In that case, it was x cubed plus 6. And when you're trying to take the integral of f of mx plus b, and you know the integral of f of x. So that's like the first problem. So the integral of sine of 2x, we know what the integral of sine of x dx is. And in this case, we set u equal to mx plus b. So here's a practice problem. And if you want, go ahead and pause the video here and give this problem a try. All right, so here's the answer. So in this case, we have f of mx plus b, where 2x plus 3 is the mx plus b. So we set u equal to 2x plus 3. And then differentiating both sides of the equation, the left side becomes du over dx, and the right side just becomes 2. And then we isolate dx by multiplying both sides by dx and dividing by 2. Okay, and then we substitute these values back into our original integral. So 2x plus 3 is equal to u, and then dx is equal to du over 2. And then we have a constant 1/2 right over here. So we can just move that out of the integral. And then we have the integral of 1 over u du. We know that's the absolute, we know that is ln of the absolute value of u. And then now we unsubstitute u equals 2x plus 3. And then this right here is our final answer. All right, here's another practice problem. So the answer, so you notice that you have x squared right over here, and you also have its derivative. So therefore, you set u equal to x squared. All right, and then differentiating both sides of the equation, the left side becomes du over dx. The right side becomes the derivative of x squared, which is 2x. And then you isolate dx. All right, and then you substitute. So x squared is equal to u, and dx is equal to du over 2x. So now we have 2x in the numerator and the denominator, so they cancel each other out, leaving us with the integral of e to the power of u du. And we know that that is just e to the power of u. And then unsubstituting u equals x squared, we get that the final answer is e to the power of x squared plus c. All right, here's another practice problem. So the solution, if you think of it as this, then you'll see that you have x squared plus 1 and its derivative 2x. So you set u equal to x squared plus 1. And then differentiating both sides of the equation, the left side becomes du over dx and the right side becomes 2x. So then you isolate dx. All right, and then now we substitute. So x squared plus 1 is equal to u, and dx is equal to du over 2x. So the 2x's cancel each other out, leaving us with 1/2 times the integral of 1 over u du. So we know what the integral is. And then finally, we unsubstitute u equals x squared plus 1. And this is our final answer. So now here is integration using other standard integrals. And the standard integrals are like the integral of sine of x, cosine of x, but there are some other ones. So take, for example, this integral right over here. The way you solve this is so 2x squared is the same thing as parentheses, the square root of 2 times x, close parentheses, squared. All right, and then you set u equal to the square root of 2 times x, and then differentiate both sides of the equation, and then you isolate dx, so you get dx is equal to du over the square root of 2. All right, and then substitute, so this right over here, the square root of 2 times x is equal to u, and then dx is equal to du over the square root of 2. All right, so you move the constant 1 over the square root of 2 out, and then this is what you're left with. And if you remember, the derivative of arctangent of x is 1 over x squared plus 1. So that means that the integral of 1 over u squared plus 1 du is equal to arctangent of u. All right, so then we unsubstitute. So u is equal to the square root of 2 times x. And then we get that this right over here is our final answer. So here are some standard integrals to remember, and you should probably remember them because they might show up in AP Calculus AB. All right, so now knowing that, try this practice problem if you want. The answer. So you factor out a constant, and that constant is 4 because you see there's a plus 4 right over here. So you factor that out, and then you can just carry that out of the integral. And then x squared over 4 is the same thing as the quantity x over 2 squared. So now you set u equal to x over 2, and then differentiate both sides of the equation, and then isolate dx. So now substituting, x over 2 is equal to u, and dx is equal to 2 times du. So we can carry this constant 2 out of the integral, and then we have this integral right over here, which we know is arctangent of u. All right, and then unsubstituting, u is equal to x over 2. So our final answer is 1/2 arctangent of x over 2 plus c. And here's a harder u-substitution example. You don't need to know this for AP Calculus AB, but just watch the solution to it because it will help you better understand u-substitution. So in this problem, you set u equal to the square root of x plus 1, and you differentiate both sides of the equation. You'll get that du over dx is equal to 1 over 2 times the square root of x. And then isolating dx, you'll get this. So then substituting the values into the original integral, this right over here becomes u, and dx becomes 2 times the square root of x du. And now notice that we have du right over here, but we still have an x. And since we already have du, we cannot have any x's. So how can we get rid of this square root of x? Well, if you look what we substituted what we set u equal to, and then we subtract 1 on both sides, you can solve that the square root of x is equal to u minus 1. And then you can substitute that in. So now this integral becomes pretty easy. So simplify and then take the integral of each term. All right, and then you can carry the constant out for this one right over here. And then solving for these integrals, you'll get 2u minus 2 times natural log of the absolute value of u, and then unsubstituting, you'll get this. And then after you distribute, you'll get this. And then you put a plus c at the end. And notice that we have a plus 2 and a plus c. They're both constants. So instead of keeping this plus 2 right over here, we can just get rid of it and then change this c into a c1. All right, so that's the end of u-substitution. So if you only care about doing well in AP Calculus AB, you don't need to watch this part about partial fractions. I will put a Khan Academy link in the description where you can get more practice with u-substitution and learn about the integration methods, long division, and completing the square. They're both pretty simple. And you already gotten a head start with completing the square because it involves using the derivative of arctangent of x. But anyway, here's integration by partial fractions. So before we get in, you should remember this fact right over here, which comes from u-substitution. The integral of q over mx plus b dx is equal to q over m times the natural log of the absolute value of mx plus b, and then plus c. So this fact is vital to integration by partial fractions. So here we go. Here's an example of a problem that you can integrate using partial fractions. So first you break this down. You factor the denominator into x plus 3 times x plus 2. And this can be broken down into a over x plus 3 plus b over x plus 2. And then multiply both sides by the denominator right over here. You'll get this, and then distributing and grouping together the terms with and without x on the right side, you'll end up with this. And now you have a system of equations because 2 is equal to a plus b and 5 is equal to 2a plus 3b. And solving this system of equations, you'll get a is equal to 1 and b is equal to 1. So going back to our original decomposition and plugging in the values for a and b, you'll get that this fraction right over here can be broken down into 1 over x plus 3 plus 1 over x plus 2. So this was our original integral, and we've broken down the fraction into this. So this integral right over here is a lot simpler. You can just take the integral of each term, and then using the fact from u-substitution, you can solve for these integrals and get ln of the absolute value of x plus 3 plus ln of the absolute value of x plus 2 plus c as your final answer. So now, if you want, go ahead and try this practice problem by yourself. Here's the solution. So you factor the denominator into x plus 2 times x plus 4, and then this fraction can be written as a over x plus 2 plus b over x plus 4, multiplying both sides by x plus 2 times x plus 4. You get this, and then distributing the right side and grouping together the terms with and without x. We get this system of equations: 3 equals a plus b, and 10 equals 4a plus 2b. If you solve, you'll get that a is equal to 2 and b is equal to 1. So now we can plug that into our original decomposition. All right, so we've broken down this fraction into this right over here, and then solving for this integral. So take the integral of each term, and you can carry out this constant, and then solving for each of these integrals, you'll get that this right over here is our final answer. So here's another practice problem. To solve this, you would factor the denominator into 2x plus 1 times x plus 1. And this fraction can be broken down into a over 2x plus 1 plus b over x plus 1. And multiplying both sides by this denominator, you'll get this. And then distributing on the right side and grouping together the terms with and without x, you'll get 7 equals a plus 2b and 4 equals a plus b. So solving, you'll get that a is equal to 1 and b is equal to 3. And then you can plug those in to our original decomposition. So we've broken down this fraction into this, and then solving for this integral by first taking the integral of each term and carrying out the constants. And from the fact that we get from u-substitution, we will get that the final answer is this: 1/2 times natural log of the absolute value of 2x plus 1 plus 3 times natural log of the absolute value of x plus 1 plus c. And that is the end of this video. So stay tuned for the next video, where we'll dive into even more integration methods.